Welcome to my YouTube channel. Please don't forget to subscribe, like, and share.
Welcome back to our ALE review series practice quiz, and this is now part 7 of our structural conceptualization quiz. So instructions before proceeding with the quiz, it is best to get a piece of paper muna, cut lengthwise, and then write down numbers 1 to 30 so that when you are ready, you can now start with the quiz, and for every question, write down the corresponding letter of your best choice or answer from the multiple choice. And you will be given 10 seconds to finalize your answer. At the end of the quiz, count the total number of your correct answers and check your score rating. So if you are now ready, good luck. So number 1, an instrument used to measure deformation. A. Strain gauge. B. Extensometer. C. Deformation measuring equipment. And D. None of the above. And our correct answer is B. Extensometer. So, both extensometers and strain gauges are instruments used to measure deformation. A strain gauge is very small and measures local strain at a point on the surface. It's widely used in material testing and experimental stress analysis. An extensometer is designed to measure elongation, contraction, or deformation of structural elements, like the change in length of a specimen in a tensile test, or deflection in a structural member. So if the context is structural elements like beams, columns, trusses in civil structural engineering, the more correct answer is extensometers. Number 2, an instrument used to measure velocity and acceleration of an earthquake. A. Seismograph. B. Geiger counter. C. Accelerograph. And D. None of the above. And our correct answer is letter C, accelerograph. So accelerograph measures velocity and acceleration of ground motion during an earthquake. A seismograph measures the displacement or ground motion caused by an earthquake, while Geiger counter measures radiation, not earthquakes. Number 3, which is the best column? A. Square. B. Rectangle. C. Triangular. And D. None of the above. And the best answer is letter A, square. So a square column gives uniform strength and stiffness in both directions, making it the best among the choices for structural stability. A circular column, however, is often considered the best overall since it has no weak axis, gives uniform strength in all directions, and resists buckling better than other shapes. This makes circular columns ideal for bridges, high-rises, and structures where both performance and aesthetics matter. Number 4. A transformer volt is considered a blank. A. Live load. B. Dead load. C. Concentrated load. And D. Uniformly distributed load. And the correct answer is letter B, dead load. So a transformer volt is part of the building structure and is therefore treated as a dead load since it is a permanent fixed weight. Number 5, which is dangerous? A. Shear wall with many openings. B. Shear wall at the center. C. Shear wall at the outer edge of building. And D. None of the above. And our correct answer is letter A, shear wall with many openings. So the most dangerous case is a shear wall with many openings. Openings like doors or windows in a shear wall interrupt its continuity, reduce its stiffness, and create weak points where cracks and failures can occur during lateral loads such as earthquakes or wind. Number 6. Where do shear walls rest? A. Footing, B. Foundation, C. Ground floor, and D. Second floor. And our correct answer is letter B, foundation. So shear walls must transfer lateral loads safely into the foundation system. They are built continuously from the top of the structure down to the foundation, where they rest and anchor. A footing is just one component of the foundation system. It's the widened concrete base that spreads the load from the column or wall into the soil. The foundation, however, is the entire system that includes the footing, mat, pile caps, or any structural element that transfers loads safely to the ground. So, when we say shear walls rest on the foundation, it means they are anchored to the whole system that supports the structure, not just the footing alone. That's why the more correct answer is foundation rather than footing. Footing would be correct only if the question is very specific about shallow foundations. Number 7. Over-reinforced concrete is blank. A. More dangerous than under-reinforced. B. Less dangerous than under-reinforced concrete. C. Equal. And D. None of the above. And our correct answer is letter A, more dangerous than under-reinforced concrete. Over-reinforced concrete is more dangerous than under-reinforced concrete. In an over-reinforced section, the steel ratio is too high. So, the concrete crashes first before the steel yields. This leads to a sudden, brittle failure without warning. On the other hand, in an under-reinforced section, the steel yields first, giving visible deflection and cracks before failure, which is safer because it provides warning signs. Number 8. Which is more dangerous during an earthquake? A. Rupture, B. Shaking, C. Sublimation, and D. None of the above. And our correct answer is letter A, rupture. So during an earthquake, the most dangerous effect is rupture. Rupture refers to the actual breaking or tearing of the ground or structural elements, which can cause catastrophic failure. Number 9. What resists bending stress? A. Section modulus, B. Rigidity, C. Moment of inertia, and D. None of the above. And our correct answer is letter A, section modulus. The section modulus is a geometric property of a beam's cross-section. It's a direct measure of the strength of the beam and its ability to resist bending. A beam with a larger section modulus is stronger and can support greater loads without deforming or failing. Number 10. What usually happens to steel in a slab or reinforced concrete beam if such member is about to collapse? A. Crack, B. Rupture, C. Deflect, and D. None of the above. And our correct answer is letter C, deflect. In a reinforced concrete beam or slab, when the member is about to collapse, the steel reinforcement yields and causes large deflection. So in an under-reinforced member, the standard design, the steel yields and the beam shows excessive deflection before collapse, providing warning signs. Crack happens first in the concrete, since concrete is weak in tension, but that alone does not mean collapse. Rupture happens only in over-reinforced members, that is sudden brittle failure, but this is not the usual case since codes require under-reinforced design. 11. What happens when a column rests on a footing that is not reinforced with rebars? A. The footing will crack at an angle. B. The column will punch a hole through the footing. C. There will be noticeable settlement. And D. None of the above. And our correct answer is letter B. The column will punch a hole through the footing. When a footing is not reinforced with rebars, it becomes weak in tension and shear. The high concentrated load from the column transfers directly to the footing, which can't resist punching shear. This usually causes the column to punch through the footing. That is a common failure mode in plain, unreinforced concrete footings. So number 12. While traversing EDSA, you will see the elevated MRT. What do you call the concrete portion of the MRT running parallel to the road where the tracks of the train are placed? A. Rail beam. B. Girder. C. Box girder. And D. None of the above. And our correct answer is letter A, rail beam. So in an elevated railway, a rail beam is a main structural component that supports the railway tracks and the train's dynamic loads. The most common materials for elevated railway beams are steel and prestressed concrete. Prestressed concrete is often preferred because it's highly durable and requires less maintenance and can span long distances while remaining slender. There are different cross-sectional shapes for these beams, including box girders here, that is a hollow rectangular shape in yung sa may Aurora Boulevard, and I girders din nasa EDSA, resembling the letter I. Box girders are often used because their shape provides excellent torsional stiffness, which is crucial for elevated structures. Number 13. Standard 90-degree bend shall consist of extension at the free end of the bar equal to blank. A. 8 dB, B. 10 dB, C. 12 dB, and D. 16 dB. And our correct answer is 12 bar diameter. So the term standard hook shall mean one of the following, and that is a 90-degree turn plus extension of at least 12 bar diameters at free end of bar. Number 14. The minimum clear spacing between parallel bars in a layer shall not be less than blank diameter. A. 20 mm, B. 25 mm, C. 40 mm, and D. 50 mm. And our correct answer is letter B, 25 mm. So this spacing, the clear distance between parallel bars, that is except in columns, shall not be less than the nominal diameter of the bars, or 25 mm, except that bars in splice may be in contact. Number 15. The standard hooks for the stirrups and ties shall be blank. A. 90-degree bend plus 6 dB extension at the free end of bar for 16 mm and smaller. Letter B. 90-degree bend plus 12 dB extension at the free end of bar for 20 mm and 25 mm diameter. And C. 135-degree bend plus 6 dB extension at the free end of bar for 25 mm and smaller. And letter D, all of the above. And our correct answer is letter D, all of the above. So this is the minimum inside bend diameters and standard hook geometry for stirrups, ties, and hoops for 90-degree hook and for 135-degree hook and 180-degree hook. So for the extension, that is greater of 6D and 75 mm for number 10 through number 16 bars. And 90-degree hook, that is 12 diameter extension for number 19 through number 25 bar size. And then for the 135-degree hook, we have greater of 6D and 75 mm for number 10 to number 16 or number 19 through number 25 bar sizes. So number 16, in a spirally reinforced or tied reinforcement compression members, clear distance is blank. A. 1.5 dB, B. 2.0 dB, C. 5.0 dB, and D. 1.0 dB. And our correct answer is letter A, 1.5 dB. So for longitudinal reinforcement in columns, pedestals, struts, and boundary elements in walls, clear spacing between bars shall be at least the greatest of 40 mm, 1.5 diameter, and 4/3 of D of aggregates. 17. Where parallel reinforcement is placed in 2 or more layers, bars in the upper layer shall be A. 20 mm, B. 25 mm, C. 40 mm, and D. 50 mm. And our correct answer is letter B, 25 mm. So for parallel non-prestressed reinforcement placed in 2 or more horizontal layers, reinforcement in the upper layers shall be placed directly above reinforcement in the bottom layer with a clear spacing between layers of at least 25 mm. Number 18. In walls and slabs other than concrete joist construction, primary flexural reinforcement is blank. A. 300 mm, B. 400 mm, C. 450 mm, and D. 500 mm. And our correct answer is letter C, 450 mm. So the spacing S of longitudinal bars in cast-in-place walls shall not exceed the lesser of 3/8 and 450 mm. And if shear reinforcement is required for in-plane strength, spacing of longitudinal reinforcement shall not exceed L over 3. So 19. Bundled bars shall be enclosed within stirrups or ties but bars larger than blank mm shall not be bundled. A. 28 mm, B. 32 mm, C. 36 mm, and D. 40 mm. And our correct answer is letter C, 36 mm. So bars larger than a 36 mm diameter shall not be bundled in beams. 20. A standard hook may consist of a 180-degree bend plus a 4 dB extension at free end of blank. A. 55 mm, B. 60 mm, and C. 65 mm, D is 85 mm. And our correct answer is letter C, 65 mm. So this is for a 180-degree hook for number 10 through number 16 or number 19 through number 25 bar size. The extension is greater of 4D and 65 mm. Number 21. In joist construction, rib shall not be less than 100 mm in width and shall have a depth of not less than blank times the minimum width. A. 2, B. 2.5, C. 3, and D. 3.5. And our correct answer is letter D, 3.5. So the overall depth of rib shall not exceed 3.5 times the minimum width. 22. For T-beam construction with a slab on one side only, the effective overhanging flange shall be blank. A. 1/12 the span length of the beam. B. 1/2 the clear distance to the next web. C. Smaller of the above. And D. None of the above. And our correct answer is letter C, is smaller of the above. For T-beam construction with a slab on one side only, that is an L-beam case, the effective overhanging flange width is taken as the smaller of 1. 6 times the slab thickness. Second, 1/2 the clear distance to the next web. And third, 1/12 the span length of the beam. So this limitation ensures that the slab portion acting as flange for the T-beam does not extend excessively, which could otherwise lead to ineffective stress distribution and unsafe assumptions in design. So smaller of the above. So letter A is this one, letter B is this one, plus this one is another consideration. So the smaller of these three considerations. So one side of the web is the list of 6 times the slab thickness, or 1/2 the clear distance to the next web, or 1/12 the span length of the beam. Number 23. Maximum usable strain of the extreme concrete compression fiber shall be blank. A. 0.001, B. 0.002, C. 0.003, and D. 0.004. And our correct answer is letter C, 0.003. So the design assumption for concrete states that the maximum strain at the extreme concrete compression fiber shall be assumed equal to 0.003. 24. A property of material to expand or contract by foreseeable amounts when it is pulled or compressed and regains its shape when these forces are released. A. Elasticity. B. Rigidity. C. Compressibility. And D. Flexibility. And our correct answer is letter A, elasticity. So elasticity is the property of a material to deform, that is stretch, compress, or bend under load and return to its original shape once the load is removed. On the other hand, rigidity is the resistance to deformation. Compressibility is the ability to decrease in volume under pressure. And flexibility is the ability to bend easily, but does not necessarily imply returning to original shape. 25. A force which tends to shorten a member laterally. A. Tension. B. Compression. C. Bending. And D. Torsion. And our correct answer is letter B, compression. So for compression, it is the force that tends to shorten or squeeze a member. As compared to tension, it is a force that tends to elongate or stretch a member. Bending is a force or moment that causes a member to curve. And torsion is a twisting force. 26. A pressure due to a push from retained earth. A. Soil-bearing pressure. B. Surcharge pressure. C. Earth pressure. And D. Hydrostatic pressure. And our correct answer is letter C, earth pressure. So earth pressure is the lateral pressure exerted by retained soil against a wall or structure. On the other hand, soil-bearing pressure is the pressure exerted by a foundation on the supporting soil. Surcharge pressure is the additional pressure from external loads on the soil surface, such as traffic or buildings. And hydrostatic pressure is the pressure due to water. 27. Tiny bubbles, usually from 0.01 mm to 0.10 mm in size, purposely brought into the cement paste. A. Honeycomb. B. Entrained air. C. Trapped air. And D. Flow air. And our correct answer is letter B, entrained air. So entrained air are tiny, uniformly distributed bubbles, 0.01 to 0.10 mm, intentionally introduced into concrete using admixtures. They improve workability, resistance to freezing and thawing, and durability. So trapped air are larger, irregular air pockets unintentionally left in concrete which are undesirable. So ito yung entrapped air versus entrained air. Honeycomb, on the other hand, is voids or gaps in hardened concrete caused by poor compaction. And 28. An anchor bolt into masonry consisting of a split malleable iron cone inserted thin end first into a drilled or cored hole. A bolt between the split halves projects outside the hole. A contraction bolt, B. Expansion bolt, C. Bearing bolt, and the extrusion bolt. And our correct answer is letter B, expansion bolt. So expansion bolt is an anchoring device used in masonry or concrete. It works by expanding through a split sleeve or cone mechanism when the bolt is tightened and gripping the sides of the hole. 29. A reinforced concrete in which internal stresses have been introduced to reduce potential tensile stresses in concrete resulting from loads. A. Precast concrete. B. Prestressed concrete. C. Plain concrete. And D. Plastic concrete. And our correct answer is letter B, prestressed concrete. So prestressed concrete is concrete in which internal compressive stresses are intentionally introduced using tension steel tendons or cables to counteract tensile stresses from surface loads. So this is how prestressed concrete is done. So it starts with tensioning the pre-stressing tendons against the end abutments and cast the beam concrete and release the beam anchorages at the end anchorages and pre-stressing the beam. So precast concrete are concrete elements cast in a controlled environment and transported to site but not necessarily pre-stressed. Plain concrete is concrete without reinforcement. And plastic concrete are fresh, workable concrete before it hardens. And lastly, number 30, a three-dimensional structural system without bearing walls, composed of members interconnected so as to function as a complete, self-contained unit with or without the aid of horizontal diaphragms or bracing systems. A. Brace frame. B. Space frame. C. Truss frame, and D. A-frame. And our correct answer is letter B, space frame. So a space frame is a three-dimensional structural system with interconnected members arranged in a geometric pattern, capable of carrying loads in multiple directions, often used for large-span roofs. A brace frame are structural system using diagonal bracing to resist lateral loads. A truss frame is two-dimensional framework of triangles, mainly for bridges and roads. And a frame is a simple triangular frame, usually for small structures. So that's the end of our quiz. Congratulations for completing the quiz. Now, count your total correct answers and determine your score category. If your rating is 15 or less, it is time for a more strategic review.
Thanks for watching. Don't forget to subscribe, like, and share.
Enroll at Atlas CDC Review for a comprehensive prep for the Architecture Board exams. Message us now.